In this video, we'll talk about significant digits. We'll talk about accuracy. We'll talk about precision. Let's begin with significant digits. What is a significant digit? And why do we need that? So for example, when somebody comes in and says, what is the square root of 2? And you go, oh, square root of 2, that's, I don't know, 1.414. Well, there's more to that number than 1.414. How many of these digits are you going to carry? Are you going to use 3? Are you going to use 4, 5, 6? How many? Each one of these is significant digits. So what's a significant digit? So let's define that first. The following are significant. The following digits are significant. What are they? 1, all non-zero digits. So an example, .414, this has 4 significant digits. I'll go sig D, or dig, has 4 significant digits. 1.29643, that has 1, 2, 3, 4, 5, 6 significant digits. 23.45. This has 4 significant digits. So all non-zero digits are significant. What about if you have zeros? Well, it depends where the zeros are. What does that mean, depends? If you have zeros embedded, between significant digits, those also are significant digits. Like what? 1.0025. Those are significant digits. 1, 2, 3, 4, 5. 5 sig digit. 102.047. All these zeros are significant digits. They're between the numbers 1, 2, 3, 4, 5, 6. 6 significant digits. .042. That's 4 significant digits. Okay, what about zeros not embedded? So zeros at the end. So if we have trailing zeros, those are significant digits if what? If the number contains a decimal point. If the number contains a decimal point. Meaning what? If I write 7.00, we know that number is 7, but the fact I wrote 7.00, that means I want 3 significant digits. If I write 200 point, again, that's a 200. If I didn't care about the answer, the significant digit, I won't put the point there. So that's 3 significant digits. If I write 15.1000, that's 15.1, but the fact I put the zeros, that's 1, 2, 3, 4, 5, 6, 6 significant digits. So now, what's not then a significant digit? So what is not a significant digit? Not significant digit? Let's see. Leading zeros. If I write this number 0.0025, these zeros are not significant digits. Or if I write 042.3, so this is 2 significant digits. This one, 3 significant digits. The leading zeros don't count. Or, so this is leading zeros, or trailing zeros if no decimal point present. So if I have a number, for example, 200, 3,500, this is 1 significant digit. This is 2 significant digits. So that's really what a significant digit. So an example, just to write how many significant digits. Let's see if you actually understood all these. I'll give you some examples, and you tell me how many significant digits. 34.7. Here's significant digits. We're going to say how many this one has? 3. The next one, 0.039. How many significant digits? Leading zeros don't count. That's a 2. 1.039. That's embedded zeros. That's 4. 5.90. There's a decimal point, we added that 0. When there's a decimal point, that trailing zero counts. That's 3 significant digits. 21000, no decimal point. That's 2 significant digits. 21000 point. That's 5 significant digits. I'm done with significant digit. Now let's look at accuracy versus precision. You'll hear them a lot, especially in chemistry. In physics, we use a lot of significant digit. In chemistry, we use a lot of accuracy and precision. So what's accuracy? Accuracy actually refers to number of significant digits. in a number. So when I write this number, how many significant digits in that number? There are 5. This number is accurate to 5 significant digits. If I write 2.4, this number is accurate to 2 significant digits. Now, precision is different. That's accuracy. Let's look at precision. This one refers to rightmost significant digit. Rightmost significant digit. So it's the place value of that digit. So if I write again 172.14, this number is precise to 2 decimal places. Or we said what? Or when you look at that digit, that's the 100th or nearest 100th. .4 is precise to 1 decimal place. And that's, we call that 10th with a TH. So precision, we look at the digit, the last digit on the right, and that will tell you this is what? Precise to 2 decimal places, this is precise to 1. Which one is more precise out of these two? 172.14 is more precise than 2.4. Which one is more accurate? Accurate deals with significant digits. This has 5, this has 2. So just an example on that. I'll write a couple of numbers here. Let's say you are given these numbers. You are given 0.15 and you are given 31.2. Which number is more precise? Remember, precision refers to the digit on the right, the most precise one, the one on the right. The one on the right, that's a 10th. This is a 100th. Which one's more precise? The 100th. Which number is more accurate? Accuracy deals with the number of significant digits. This one has 2 significant digits. This one has 3 significant digits. Who has more? The 3 significant digits. As I said before, a lot of the work that we do in other classes, they'll tell you to round your answer to 2 significant digits, 3 significant digits. I use my math lab in some of my classes, and you might have a number when you're doing the calculation here. You might have an answer at the end of the work there. Let's say your answer is 3.7294. But now next to it they said round to 3 significant digits. If you type that number, you got it wrong. That means you can only have 3 digits, 3 non-zero digits here. So the 3 has to stay there, the 7 has to stay, but now the 2, since that number, this is the 3rd significant digit right here. That's your 3rd one, 1, 2, 3. But since that number is 5 or more, you add 1 to this. That's more than 5. So that number becomes 3.73. Another one, let's say your answer is, you're doing a calculation here on how high the plane was flying, and we said it's 29,472 feet. But they say round your answer to 2 significant digits. This is the 2nd significant digit, 1, 2. Now, is the 4 5 or more? No, it's not. So we don't add 1 to this. So my answer becomes 2, 9, and you replace the rest of them with zeros. That's 2 significant digits. You don't put a 0 here, because if you put a 0 there, or a period, you have 5 significant digits. So that number is 2,900. Or 1,000, I'm sorry, 1,000. Okay, now you're doing a bigger problem. And somebody comes in and says, can you tell us what the answer to this? This is an example. Can you tell me what the answer to this? 1.23 plus 13.56 minus 2.4 plus the 12. If we take the calculator and push these buttons on it, our answer is going to be what? 24.39. But, wait a minute. If you write 24.39, we got it wrong. Why? Because when, I'm going to put it in red here, when adding or subtracting well, these numbers are approximate numbers. When adding or subtracting numbers, I'm going to say numbers. Round to least precise. Here we go. I'm going to underline that. Least precise. Precision is the place value of the last digit on the right. This one is nearest what? Precise to nearest hundredth. This is nearest hundredth. This is nearest tenth. This is a whole number. There is no decimal to it. So that answer now, it's no longer 24.39. It becomes, we take the 24.39 and we change that to 24. This is the least precise number. The least precise, no decimal values. So my answer should not have any decimal values in it. Let's try another one. $232.56 plus 1,600 plus 3.5. Again, add all the numbers. Our answer should be what? 1836, if I push the right button, 0.06. But let's wait and look at it. When you're adding and subtracting, you want to use the least precise. The least precise number is this number. Notice that's nearest to what? 100. That means I got to round my answer to nearest 100. This is nearest 10, 10th, nearest 100th, nearest 100. So I need to take this number around the nearest 100. This is the 100 location. Is that number 5 or more? No. So this number will turn to 1800. I'll try another example in case you didn't get it. 5.402 plus 17.2345 minus 8.23. Again, push the button on the calculator. Your answer is 14.4065. Let's see which one is the least precise. Precision is the place value of the last digit on the right. This is the least precise. Notice the nearest what? 100th. So I need to round my answer nearest 100th. This is the 100th location. Is that number 5 or more? Yes, we add 1 to this. So the answer is 14.41. So when you add and subtract, you always want to use what? Where is it? Oh, when adding and subtracting numbers, round to the least precise. I was looking for that statement. Least precise. I don't know if I can highlight that. I don't want to ruin it. When adding or subtracting numbers, round to the least precise. What about when you're multiplying or dividing? So again, I'll make it in red because I want it to stand out. When multiplying, M or dividing, approximate your answer you need to round them to what? Round to least accurate. Remember, accuracy refers to the number of significant digits. Least accurate. Let me see if I can highlight that again. least accurate. Here's an example. 15.56. You want to multiply that by 1.80. Again, take the calculator, push the buttons. Here's your answer. 28.008. Well, let's look at accuracy. How many significant digits here? We have 4 significant digits. How many significant digits here? 3 significant digits. So your answer should be 3 significant digits up to here. Is that 5 or more? No. So your answer is 28.0. You have to put the 0 there to make sure that's 3 significant digits. Another example. 0.025 divided by 15.00. You do the math, and it's 0.001666 repeats. Now, this number here has 2 significant digits. This number has 4 significant digits. So I want my answer to have 4 significant digits. The leading zeros don't count. I mean, 2 significant, that's it, 2 significant digits. The leading zeros don't count. So that's my second significant digit. Is that number 5 or more? Yes, we add 1 to that. So that answer will be 0.0017. Okay, I think we get the hang of multiplication, division. We do least accurate, number of significant digits. What about if you have more than one operation? You have multiplication, division, addition, subtractions. Well, when you have more than one operation, we look at the loss operation. So when, let me write that up there. When doing combined operations, comma, the final answer, the final operation determines how the final result is rounded. Here's an example. $38.3 minus 12.9 times negative 3.58. If you remember your order of operations, you got to multiply these numbers first. You end up with some negative number, then you add, you go at 38.3 minus, let me get a calculator here. $12.9 times 3.58 there'll be a negative 46.182 minus a minus, that actually becomes 38.3 plus 46.182, and the answer is 91.2. See if I get the right answer actually here. 12.9, somebody just said I have the wrong number, times 3.58, I'm horrible with the calculator. It's 46.182. So add to it 38.3. I got 91.192. Double check the math. 7, looks like it should be an 8. Let's see, 38.3 plus 46.182. 84. I don't know why I got that number. You're correct, you're right, I'm wrong. 84. I am horrible with calculators. I can't see anything on them. My eye is not that good. So 84.482. Now let's look at the last operation. The last operation was what? Addition. Or subtraction, addition or subtraction. When you add or subtract, when adding or subtracting numbers, round to least precise. Precision is what? The place value of the digit on the right. This is the least precise right here. Nearest tenth. So my answer should be rounded to nearest tenth. So this one should be, that's the 10th location. Now is that 5 or more? Yes, we add 1 to this. 84.5. Try another one. 46.2 times 29.3 plus 8.74. So you do what's inside the parentheses. So that's another example. 46.2 times 29.3 plus 8.74. Oh, I got a syntax error. 29.3 plus 8.74 equals. I got 38 point, I think it says 04 if I see it there. Now I'm going to multiply. So let's multiply the two numbers times 46.2, and your answer is 1757.118. Now let's remember again, when multiplying or dividing numbers, round to least accurate. Accuracy is the number of significant digits. How many significant digits here? 3. How many significant digits here? 4. My answer should have 3 significant digits. That's my third significant digit, the 5. I look at that number, that's 5 or more. Yes, add 1 to this. My answer is 1760. 3 significant digits. Now there's one more thing about mixing operation or doing stuff like this, one more rule, and that is when doing operations with an exact number, and an approximate number, like a decimal number, The approximate number will rule here. Determines how you round. $700 plus 2.7. Again, when you add, use the least accurate, but since you have an exact number with an approximate number, this one is going to determine what the answer should be. So when you do the math, this is 702.7. Least accurate. We said the exact number is going to determine. Now, this is the exact number. This is the approximate number. Accuracy is the number of significant digits. This has 2 significant digits, this has 1. But we use that one because that's the approximate number. I need my answer rounded to 2 significant digits. When you're adding and subtracting, round the least. When you're adding and subtracting, we do a least precise. Precise is the place value of the last digit. I might have said it wrong. I wrote it right, but I might have said it wrong. Addition and subtraction numbers round to least precise. Precision is the place value of the last digit on the right. So my answer should have 1 decimal place. If I'm multiplying, like again, if I do this, 1200 minus 14.27, notice this is actually more precise, so my answer should have 2 decimal places in it. $1185.73. If I'm multiplying here, 500 times, 3.2. The calculator says, what's 500 times 3.2? It says the answer is, let's make it 3.7. What's 500 times 3.7? 1850, my calculator says. When you multiply or divide, least accurate. Well, we use accuracy. Accuracy is the number of significant digit. Again, when you mix a whole number with an approximate number, the approximate number is going to rule. This has 2 significant digits. So my answer will have 2 significant digits. There's the second significant digit. Is that 5 or more? Yes, we add 1 to this. So the answer is 1900. We don't care how many significant digits this one has because that's a whole number. Example, 4,000 times 3.13. This one is going to determine. My answer is going to be 3 significant digits. You're multiplying. Least, we go accuracy, and we go by the approximate number, so 3 significant digits. So let's see what the calculator says. 4,000 times 3.13. It is 12520. I have to use 3 significant digits. That's my 3rd significant digit. So you look at that number. Is that 5 or more? No, it turns to a 0. So my answer is 12500. And that's the end of significant digits, accuracy, and operations on them. Hopefully that helps.